We are here.
Hello everyone, can you all hear me?
Yeah,
Yes.
Yes.
Okay, I'm sharing the screen. So guys, in the last class, we actually started with the train test splitting topic and discussed about machine learning basics. Remember everyone, the machine learning part?
yes.
Good. So just quickly tell us what is machine learning, what is supervised machine learning and unsupervised and reinforcement. Who will tell this to us? See, in machine learning, you had three component guys, right? The first one was supervised, unsupervised, reinforcement. So yeah, who will tell guys? What is these three things?
Yeah, supervisor has input and output data we will provide to machine, and then unsupervised we have only input, but we don't provide any output data. And the reinforcement has feedback. It will give feedback to
It has rewards and punishment as well.
yeah, reinforcement. Yeah, it will give some feedback, and yeah, it will give some punishment as
It has agent and environment. Mhm.
That's correct, Rohit? Right.
Good. Pramila, can you tell us what these three things are?
Yeah, supervised is like if somebody is asking year-wise salary, so year goes to the input and the salary based on the salary is goes to the output. So how like the input is the year, how many how the year is working, and then the output is salary. So that's its work for supervisor. Unsupervisor is like just only input. There is no only input and just showing the like something you can say, but there is no clarification like that. And the reinforcement, like the agent environment will be there.
Like what exactly agent involvement in the reinforcement? Could you explain a bit more?
Like agent will be interact with the environment and get the feedback.
Perfect. Good.
Thank you, sir.
Now guys, today we will be beginning with the topic that is supervised machine learning. So here we have both input and output variable. That is the first thing. Okay, here you will be having both input and output variable or column. Means some sort of supervision is involved. This is called as supervised machine learning. Now guys, inside supervised machine learning, you have two component types of supervised machine learning. You have two type guys here. The first type is regression and second is classification. Regression type and classification type. So we'll first understand what is regression problem and then we'll understand what is classification. Okay. So regression. So the first point is it is a type of supervised machine learning, correct? It is a type of supervised machine learning where our output column is continuous. Where our output column is continuous. What is the meaning of continuous output column? Continuous means
Endless.
every value will be different.
Oh.
Yeah. Guys, any example for continuous data?
It's like a changing.
Just like a medical records, continuously we are getting a medical records.
Correct? Yes. So one example, if I put here, the same example, years of experience and then salary.
So this one is year-wise salary, right?
Yes, you can say 3.1 year experience. The salary is $70,000. Then 2.5, you have 41. So means you will realize one thing, every value is different in itself, right? See the output. Where output column is continuous. Don't look at the input, which is my output column here. This is my output column. And see, it is keep on changing. No two values are same. Means every column is keep on changing. That is called as your continuous data. House price in a city, every house price will be different. Correct? The house you are staying, I am staying. So every house a different price. That again one of the example of continuous data. Understood, guys? What is continuous column?
Yes.
Okay, I'm giving the access weight.
Thank you.
So regression means, guys, your output column will have continuous data or regression type of data. And this is called as regression. Then you have something called as classification problem. Because see, supervised machine learning means two things, regression and classification. So what is the meaning of classification? Here every value in the output column I should not say this, wait. It is also a type of supervised problem where the output column will have the classes, okay? Will have the classes. It will show the classification actually. What classes I mean? See, based upon resume score and placement marks, you are just detecting a learner got placed or not. Placed or not. So you can think like this. This is your output column. Okay. And these two are input columns. Classification means where output column will have the classes. Okay. So what classes? Let's say placed, not placed, right? One means placed, zero means not placed. So how many class you have? Two class, 0 and 1. This is called as classification type of problem. A person is diabetic or non-diabetic, having breast cancer or no. See, this kind of data will have the classes. It does not have a continuous data. Why it is not continuous? Because continuous means every value will be different, correct? But see here, the values keep on repeating in itself. Here you have the classes. This is called as classification type of problem. Understood, everyone? What is classification type of problem?
Yeah, it's kind of
Please.
like you were talking about the emails, like either spam email, not spam email.
Yeah, good. That can be one of the example. Any other example, guys, you wanted to state for classification?
It's like a repeating data, right? Like a group, something.
Yeah,
One
we have
file.
the groupings, exactly.
We talk of maybe data giving yes or no.
Yes. So it is not always like binary classification. You can also have three classes. Yes, no, maybe. Correct?
Maybe. Okay. Yes.
So you can have more than two class also.
Mhm.
there will be some problem statement where you will be having, let's say, 10 classes. Okay, that is also a classification problem.
If
So
the
when you look
result,
at the data,
if the
tell me.
result is, if the result is 0, 1, it's not different. Is that or it's more than 0 and 1?
It can be more than 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. Correct?
Mm-hmm.
It is
If it
possible.
is,
Okay.
if it is 0, it's only 0 and 1 is not class.
No, it is
regression.
classification. Listen. If you talk about classification here, you have two types. Still, you can say two types. When we have two class, say 0 and 1, it is called as binary classification. Okay. More than two classes. Okay. For example, how many classes? 4 classes. This is called as multi-class classification. Clear, Abrar? Both are classification. It's just that binary or multi-class. Okay.
Gotcha. Thank you.
Okay, guys. Let's start with the first algorithm that is called as linear regression. Okay. So now whatever algorithm we will be learning, linear, logistic, SVM, KNN. So either it will be classification or regression, or some of the algorithms is capable enough to solve both the type of problem, that is classification and regression. So we'll start with the first algorithm, that is linear regression. So yeah, Abrar, tell me what is regression and classification? Abrar, what is regression problem and classification problem?
I think regression program, as my understanding, there is the result is the result is
Continuous.
Yeah, the result is continuous, or that is a different kinds of result. But the linear regression is output and the input are predetermined. We are known, but there is a variation between two. I think it is a correction by my understanding. Linear regression is output and input is are given, but we are making to a correction like there is a different. It's a correction method. I think that one is
Okay, let's see.
predetermined.
Okay. Okay, guys. So what exactly linear regression machine learning algorithm means? This is the first algorithm. Okay. Let me just write the full name. Linear regression machine learning algorithm. Go on mute. Yeah. Now, what exactly this machine learning algorithm is all about, and it comes under regression or classification, let's understand. So first, it is a type of supervised machine learning algorithm, and it is used to solve regression type of problem. it is used to solve regression type of problem. Okay. So same example I can consider here. I'll just show you one data set, guys. This is the years of experience. This is the salary data. Okay. So it's a regression problem. Why? This is your output and this is my input. So output is continuous data. Yes or no, guys? It is continuous. Remember? So it is a regression problem. Okay. Clear?
Yes.
Okay. Let's understand how this machine learning algorithm actually works. How linear regression algorithm works. The first thing, this machine learning algorithm always try to fit best fit line. What it means, guys? See, this algorithm is inspired by the structure of, by the concept of equation of a straight line. Equation of a straight line. So what exactly it means? Listen, let's say in your class school days mathematics, you must have seen this kind of equation. Okay. If I plot a straight line, this is a straight line, right? Equation is y equal to mx plus b. All right. So y is the output, m is the slope, correct? X is the input, and b is what?
Intercept.
Intercept. Good. So this is your x, this is y, and this is called as slope. Slope is the angle between line and x-axis, correct? Let's say line goes like this. So angle is higher, so your slope will also higher. What is intercept? So here your x and y both are 0. This is called as intercept. The value of y when your x is what? 0. On the y-axis, your x is 0. On the y-axis, x is 0. So this distance is called as what? Intercept. Intercept means the value of x when your y is 0. Let me just write it. What is the meaning of intercept? The value of y when x is 0. The value of y when x is 0. This is called as your intercept, guys. Okay. Now, what I was telling you, this machine learning algorithm basically inspired by the equation of a straight line. This is the equation of a straight line. From this line only, our machine learning algorithm is inspired. So let me write the equation. Now, equation becomes like this. We write y equal to, okay, one more thing. We have two types of linear regression. The first one is simple linear regression, guys. What is the meaning of simple linear regression? Here we have one input and one output column. Okay, if you have only one input and only one output, that is called as what? Simple linear regression. So this example is sufficient. Let's say you have x is input, right? And y is output. Okay, this is called as what? Input. This is called as output. So in the case of simple linear regression, the equation looks something like this. Y equals to beta naught plus beta 1 x1. What was the equation of a straight line? Y equals to mx plus b. So guys, it has a bit changed. In place of b, what you have? Beta naught, right guys? So beta naught here is called as what? Intercept. Okay. The name is changed a bit. Here you have m, and what you have here? Beta 1. Okay. So beta 1 is called as coefficient. In place of x, you have also x1. This is called as what? Input. This is the equation of a straight line, and this is the equation of your simple linear regression. Why? Because you have single input and single output. Okay, output will be single only. How many x you have? Only one x. 1x means how many input? Only one input. Understood guys, this equation, everybody? Now I'll just write the equation of multiple linear regression, then I'll give these notes to you. You can revise. Second type is multiple linear regression. See, in simple linear regression, what you have? You have single input and single output, right? See, output column will always be single only. It's just that depending upon how many input you have. Correct? Input might be changed, but the output will only be one. Here we have multiple input column and single output column. Here we have multiple input column. How many input column? Multiple. And how many output column? Just single. So think like x1, x2, x3. Three input column you have. And how many output? One. This is what? Output. And what are these? inputs. Okay. So if I write the equation, so equation becomes y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So you don't know how many input you have. You can write here dot 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 beta n xn. That you don't know the exact count of input. So it will keep on going. You have 3 input. You will stop here. If you have 4 input, stop at beta 4 x4. Where y is the output, beta naught intercept, beta 1, beta 2 till beta n, what is called as
Input.
coefficient.
Course.
x1, x2, x3, xn. This is called as inputs. Okay, so I'm giving you these notes. Please revise it. Just give me 1 minute. Let me just rearrange it. 1 minute, guys. So guys, I have given the notes. Look at it in the chat box. Okay, please revise these notes. Download the notes, guys, from the chat box. Revise them.
Sir, the third page, the first icon, it is unable to read. It's cutting, I think. Do you see that?
You can drag it, okay, scroll it. Below you will find the segment which is cut it.
Okay, okay. Thank you.
Yeah, Govind, like what are the real-time applications of this regression algorithm in machine learning? Can you give an example?
Okay, I'm giving it, just revise it. I'm giving it for both of them, classification and regression. I'll show the website also.
Okay, yeah, sure. Thank you.
Guys, done with the revision?
Let's go.
Okay. Okay, so you're asking about some real world application for this classification regression. So if you talk about classification, so there are a lot of medical devices available on the stores. Just take your blood samples and within a second they predict you are diabetic or non-diabetic. Means that machine has a software or application installed, okay, and that application have been trained upon billions of blood sample. So now machine have the idea if a blood sample contains this content in a specific quantity, that will be fall in the category of diabetes, otherwise non-diabetes. So on that places you can see an example of classification. If you talk about regression, okay, so house price detection is one of the parameter. On what parameters a price of a house depends. For example, the size of a house in the square feet, number of bedrooms, number of bathrooms, location like city, neighborhood, etc. Age of the house, nearby amenities like school, parks, malls, etc. Depending upon these parameter, that algorithm will decide the actual cost of the house. Correct? All the real estate businesses use this algorithm to accurately predict the price of a house so that they can purchase the house on a like cheap cost and sell it on a higher price. That's how they make the profit. Got it? The use cases?
Yeah, got it. Got it.
Okay, guys. So I'll just list down some of the number of steps, okay, that you will be doing in every machine learning model. So step number one, guys, you will be loading the data. Whatever data set will be given to you, you will load it. Second, you perform data pre-processing or data cleaning operation. For example, data contains some missing values, it has outliers, duplicate. So these things we check, okay? So missing value is very common that we use to check, okay? Because if data contains missing values, it will create a problem, okay? Third component you have is some sort of visualization, like you will try to understand some correlations, you chart, if you plot some graph and chart, that looks better in your hands on. Then you split your data into input and output. Yesterday we talked about, right? What is the name we have given to input? Tell me. What name we have given to input columns?
Extra.
X, right?
Mhm.
And for Y, like Y for
Small one.
output,
Yeah.
right? Small y. Very good.
Yes.
Now, guys, once we split your data, you apply what? Train test split. Next, you load the model, whatever machine learning algorithm you will be applying. So every machine learning algorithm has a model. Okay. What is model? Just like a baby, knowing nothing, you will be training the baby. And once you feel like, okay, baby have learned everything, you need to test it, the performance, how accurately the person have or the model have learned the pattern from the given data. Okay. So train, test, split, and then load the model. Then you have training process. Okay, we have to train the model. Then predict. Predict the model on new data. Okay, you will make some sort of prediction and then test the model accuracy. And then you compute the loss. Compute the loss. So these kind of some steps involved, guys. Okay, load your data set, data cleaning, visualization, splitting the data into input and output. Okay, train, test, splitting, load the machine learning model, train the model, make the model on the new data, predict the data. Okay, then whatever your model have made the prediction, it is correct or incorrect, you have to validate the performance. Correct. And then you compute the loss and accuracies at the end. So these are some common steps, okay, involved in every machine learning model. So guys, I'm sharing you one data set in the chat box. Please download it in your system. Guys, load this, just download this data set. Everyone, please download this data in your system. Okay, I believe guys, you downloaded dataset. Okay, it has just 2 column. Okay, and that's a perfect example of implementing simple linear regression. Okay, so we will be implementing it now in the Google Colab. Okay, anyways, let's have a break, and after that I will be showing you the complete implementation of this simple linear regression, and we will be also implementing multiple one where we will compute loss, accuracy, and everything. Okay, I'm putting the timer on the screen. I hope you all are back, guys, from the break. Back?
Yes.
Okay. So I will be loading few libraries here. Some sort of suggestions and warning will be coming up. For that purpose, I will be ignoring these warnings. Okay. So I used the warning library. Now we will load our dataset.
Most of we use this warning. What is the main important for that?
See, sometimes we get these kind of suggestions. See, that is in red color. This is not the error, but it doesn't look good in our code. Correct? Okay, this is extra. Let's say some libraries is going to be expired. So the notebook will keep on suggesting us that, hey, it is going to be expired in future. So that actually comes under red color. It's not an error, but it does not look good in our code. So I don't want this kind of warning to come in my Ecolab file. For that purpose, I use the warning library. Okay, Abrar? Clear?
Yeah.
So
I hear you. Thank you.
so let's load this data set, guys. I got the first 5 record. Okay. Let's check the shape of this data. Shape means how many rows and column it will have. So it has 30 rows and 2 columns. Check for some missing values. So see, it is not having any missing value. It is 0, 0, 0 here, 0 here, 0, 0. It is not having any missing value. So data is not having any sort of missing values. Okay. Now we will go for splitting our data into input and output. Input means capital X and output. So input we have X equals to, which is my input column from this. Years of experience is the input column, right? This is capital X and salary is the output column, right? So input. So from data set 1, I'll take what? Years of experience in the input column. So this is the years of experience. So see, I got the input column. In which variable? Capital X. Now let's talk about the output column. What is the output column? Salary. So from data set 1, salary. Okay. So see, this is my salary. So yeah, I'm able to get the input and output column separately. Okay, guys. Now, the next thing is apply trend test splitting. You have just one input column, guys. So there is no requirement for standard scalar. A standard scalar will be applied when you have so many input columns, right? And you see some input column have lesser value, some is small, some input column have bigger values, right? In that case, you apply. But here is specifically we have only single input column. It is not required. Okay. So I'll simply go for train test splitting. Here standard is not required since we have only single input. Single input column. Let's apply train test splitting. How to load train test splitting? What is the command? From scale and dot model underscore selection. What happened? You forgot? We did yesterday only. This is the statement or not? Or something else we need to use? Check me. Please confirm. Is the same statement or we have to use something else?
It is.
Same, right? Okay. What is the sequence of X train, X test? What is the sequence X train, Y train? What was it? Tell me. The sequence that we use. You know, we
X-train,
divide our data into training. Yeah, X train.
comma X test,
X
comma
or
Y
Y.
train,
X or
Y.
Y.
Y train and Y
Y
test.
train.
After X train, what should I write?
X text.
X train,
Y
X test.
Extrain.
train.
Very-
Y train.
Don't guess,
X
guys.
test, Y
Okay.
test.
And then Y
train, Y
train
test.
and then Y test. Y test and then
Train test is split.
Train
On
X
which data?
test.
Input and output,
Some
right?
Y test.
Yeah, size
Train
equals to
size
0.8.
0.8. What is random state? Tell me now.
42.
20.
What is the meaning of it?
80%.
Yeah. What is random state?
42.
Not change
No,
anytime
no,
you.
no. What is the meaning of it?
It
Is
means
this
the values do not change anytime you
the,
run.
the value is the same to this constant number every time when we execute.
it's like a seed value.
Very good.
Fixed.
It's a seed value and it will keep the selection part constant, right? It
Fixed,
wouldn't be
yeah.
changing every time we run the code. You can put any other value for random state from 0 to 100. Okay. What was the shape of my data? So our data was having how many rows? 30. What is the 80? What 30? 30. So what is the 80% of 30? Tell me. What is the 80% of 30?
24.
24.
24.
Really?
Yeah, 24.
24. Okay.
24. Oh, I'm on mute.
Just 1 second. .
Oh,
Okay. So let's verify the shape.
I have a question here.
See guys, it was right. So 80% of 30 is 24. So see 24 input and 24 output for training data, right? And 6 input and 6 output for testing data. Clear, all of you?
Yes, sir.
Okay, good. So for
I
so
have
far
a
what we have
question.
done, tell me quickly.
I think it is a testing. When we take testing, we take 80%. But when we are talking about the sampling and population, we have take less than 50%. So it is confusing for me that it's a
Don't get
population and
confused.
sample.
Don't get confused. In machine learning, take 80% of training data and 20% of testing data. Okay. When it comes to machine learning, that
Is
is
that 80% is a sample, right?
80%. Don't think here sample and population. Think
Okay.
that from the 100% data, you are just dividing into two components, 80% and 20%. Nothing is sample here.
Okay. Okay. Thank you.
So guys, we have done following steps, right? Train trace splitting, and we got training data and testing data. When we got this, it's time to apply the machine learning model. Okay. So we are building which one? Linear regression. Okay. Loading the model. How to load? From sklearn dot linear model. Import linear regression. Hmm. Okay, this is how guys it will be loading. So sklearn is the library. Linear model is the sub library. And this is a class. So guys, when you learn the oops concept, remember we had the class, and for every
Yes,
class we create what?
parents and child object.
Object. Class itself is not contributing in the implementation. So when we create the object of this linear regression class, so I will be giving a name it as what? Model. What is the meaning of model? It is the object of any machine learning class. Okay, that is called as model. So creating the object,
Which means 80%, right?
what 80%? No,
That
it
we
is
take
we are
about.
that is data part. We are not using this data yet. Okay, we are doing it separately, machine learning part. So that we will be used later. Creating the object. Please focus guys, this is very important. This object is called as what? Model. So model 1 linear regression. This is how you create the model. What is the meaning of model? It's like a baby which does not know anything. Okay. So guys, what is the meaning of model? Baby have no idea. So you have to train the baby. What you will do? Train the model. So when you teach the baby, okay, teach the model, teach on which data? Training data. What is training data? X train and Y train. You have to show the input as well as both output, right? You have to show input training data and output training data, because these X train and Y train both are training data or not? Tell me.
Yes.
This is the training data, guys, right? So we will be
Yeah.
using these two data for training purpose. Once your model has learned everything, then what we do? We make the prediction. Make the prediction. So it will make the prediction on which data? It will make the prediction on X text. What is X test? New input data. It will be a new data for your model, because in the learning process, what kind of input data it has seen? Training input. So it will be a new data for your model or not, guys? Tell me. Right?
Yes.
So when your model receives the new input, it will give the output. Your model takes the input, then it produces the output. That output you will store in YPRED. What is YPRED? Predicted output. What is output? Predicted output. Now, we will validate.
It's not clear this one, sir, before you go.
We will validate this YPRED with Y test. What is Y test? Actual output. So once again, I'll just let you know. Please focus, everybody. When you have so listen, guys. When you apply train test splitting, what kind of data you have received? X train, Y train, and what you have received. Let me just write in the sequence. When you apply train test splitting, what kind of data you have received? X train, X test, Y train, Y test. Yes or no?
Yes.
Now,
Yes.
step number 1, you will train the model. Train the model. For training purpose, which data you use? Training input and training output. Yes or no, Abrar?
Yep.
Yes.
So these two are used. Second step, make the prediction. What? Make the prediction. So you will make the prediction on new data. What is new input data?
X test and Y test.
Why is the output? I'm talking about the input. Make the prediction on which data?
X test.
New input data. This is the input or no output?
Input.
Okay. So when you give new input to your model, okay. So let's say this is your model. It says, hey, I will tell you the salary of the person. So you said, okay, no problem. I will give the years of experience, which is stored in X test. So it will give some output or not? Tell me. It will
With
generate the
different
output.
outputs.
Y test.
With
Yeah.
different outputs.
It will generate the output. And this
Yes.
generated output is called as Widespread.
Wide
So
breed.
somebody asks you what is widespread? It is the new output generated on new data. What is new data? X test.
Test
Abrar,
input.
clear?
Yeah, I
Yes.
think the step number two, the prediction, we take from we are X train and X test. So why we take X test to for step two? Because it is the same place on the X train
Listen,
and the X test.
X train, X test you have used already. Sorry, X train you have used already. Your model have seen everything. So in the testing process, it is not good to pass same data. We will pass something new, right? So that we can analyze, is your model able to behave properly or not? Okay. So therefore we will passing something which your model have never seen. Got it?
So it's different that X test the first one and X test the second one. That one X test
Yes.
inputs. Is there
X
different?
test is 20% data, right? We have divided into 80 and 20, right? This is 20% and this was what?
80.
So for testing, small data is also fine. Yes or no?
Yeah.
Okay.
Yes.
Good. So guys, when we give this 20% of testing data, we receive what? 20% of output? Yes or no? Now,
Yes.
the output given by your model is correct or not? For that, you should have actual output with you. Yes or no?
Yep.
We will validate the predicted output.
But I need
Wait,
explanation on step two. Step two.
listen, dear. Let me first finish it. Why you are interrupting in between all the time?
Sorry.
Okay. I will repeat it. Let me first finish it. Okay. If you listen carefully, you are in a rush of speaking. You are not listening properly. I'll repeat the same sentence multiple times. If you couldn't able to get in step number 2, you can get in step number 3. Okay. Just have some patience, please. So we will validate the widespread with actual output. What is my actual output? Y test. Okay. So once again, guys, you was having this 4 type of data. This is the last time I'm explaining. Okay. So those who couldn't able to get it, please pay attention. Step number 1, we will train the model. Okay, for training the model, you have taken input training and output training. So these two data have been used already. Abrar, listen, these two have been used, correct? 80% of input training and 80% of output training. Tell me, yes or no? Clear the first step?
Yes.
Yeah, it's clear.
Okay. When you have used these two data, it is time to test the model. You will not use the same data for testing. If you want to test somebody, you can ask a small question and you can able to understand that the person is good or not, right? So this 20% of input data that you have with you, you will use for testing process. So you have given this testing input data to the model that, hey, this is the years of experience. Can you guess the salary? So your model says, okay, how many input data you have? 20%, 6 input, right? So your output is given by the model. The output given by the model is called as what? Is called as predicted output. What is called as? Predicted output. If you have taken 6 input, this will be 6 output or not? Now, 3 of them have been used here. What is you are left with?
Y test.
This is used for validation. Actually, this is the answer of this 6 input. Yes or no? This is the correct answer. If I ask you one question, you have given the answer. Your answer is correct or incorrect. How would I decide? First, I should know the correct answer. If I am not aware with the correct answer, how can I validate you? So that the 6 output given by your model, it is correct or incorrect. Who will validate? Y test. Okay. So we will validate the predicted output with actual output. What is the actual output called as? Y test. And we get the what? Accuracy. This is the 4-step process we use. Now clear?
I think the step 2 that makes step 2. I need the step 2. I'm confusing this X test input. That place is confusing me. Everything is clear, but step 2 makes to a prediction.
Yeah. Hello. Okay. Okay. Hello, Dinesh. Could you try explaining, please? In your word. If you understood this concept.
Yeah. I'll try to explain.
Listen, Abrar. Dinesh is trying, okay? In his own word. Maybe you get it. Go.
So, Abrar, so here we have X train input, which is 80%, and Y train output. Okay. Here we need to predict the output in step 2, like make the prediction. Okay. Here X test we are giving the input, and Y test is the output that we need to generate. So here we are giving it as 20%, and Y prediction is also 20%. Okay. You understood this point, Abrar?
So step 2, we test the input means that 20%.
Yes, correct.
We predict to the 20% one.
Yes, correct. And we need to predict, it is generating some output, which we need to predict whether that output generated is correct or not. That is nothing but Y predict, which is 20%. Okay.
So we find out to the 20% part, so that's remaining on the
Yes.
top one. Okay.
Yeah, correct.
Right, thank you.
Okay. Yeah, validate the now we need to validate at the third step. We need to validate whether the output which we got is correct or not. That is what Govind is trying to explain with the actual output, which is nothing but Y test. Okay. Here we will create a model which will do that.
Abrar, okay now? Clear?
Yeah, so we find out step 2 that makes to prediction for X test means that 20% that's the top one, right? So that is why the confusion, my confusion. Thank you.
Yeah, it isn't nothing but you're just predicting the you're just creating a model and it is generating some output, but you need to validate from your end as an engineer. You need to validate the output whether it is correct or not, which is nothing but is considering it as a Y prediction, which it will validate whether the Y test is correct or not. That's it. Okay, Abra?
That means 80% we are getting the result before that we testing when we make it at the machine training. So we find out the remaining 20% for the new prediction value, right?
Yes, correct.
Okay.
Yeah, go done.
Thank you, Dinesh. Okay, so let's code it, guys, and you will get it practically also. We'll explain to you. So for example, you have just created the model. This model is very new, has nothing to do with it. Okay, it has zero idea. We will train the model. So for training, we use the fit function. Okay, model 1 dot fit. We pass input data, input training, and output training. So here the model is what? Getting trained or learning process. What data I passed? 80% of input, 80% of output. So now, is this correct? We will make the prediction on X test. Wait, prediction on X test. That is 20% data. Prediction on X test, that is 20% data. And I will store the predicted output in ypred. Take your model, apply the predict function. Predict on X test. So this is your model, guys. You apply the predict function. You are predicted on 20% of input data. And the output you are storing here in ypred. So what is ypred? Ypred is the answer given by the model. This is correct or incorrect? For that, you should have the actual output with you. What is actual output? Y test. So Y test is the actual output. In the first case, the actual output was 112,000. But your model says how much? 115,000, right? Here it is 67,000. The second actual output was 67,900. Your model says 71. So it is close, but it has some error. Yes or no, guys? This is the answer given by the model. This is the actual answer. So how much difference you have, how much your model is accurate. Okay. For that, we will compute the model performance. So in regression type of model, you apply one technique called as R2 score from sklearn dot import R2 score print R2 score. So here you will just compare Y test means what? Actual output, and ypred means predicted output. So you have just compared the actual output versus the predicted output. What is the accuracy? 0.90. It means 90.2% accuracy. Correct?
Yes.
This is how it should be. Okay. It's the same thing that we applied here. So I'm giving you both the notes. This PDF.
So finally, we add that 20% test and the previous one 80% together. After we get a prediction price, what?
We are predicting on 20% data. Okay. Not on the 80%. 80% data we are using for just training the model. And 20% data we are using for just checking the how model is accurate.
So basically, with the 80%, the machine is able to predict the pattern and then also predict the outcome from the X test, and the ypred should be the same as the Y test. Or
Yes, should be the same, but it is not. That is the difference. That is called as loss of accuracy. Correct?
yeah.
So what we want, our ypred, which is the predicted output, and Y test should be as closer as, okay? So that you can have a high accuracy. If they are far apart from each other, you will have a less accuracy. See, we got 90% accuracy because the values are not matching. It is close, but it is not accurate, isn't it?
Mhm.
See, the actual output was 112,000, but your model predicted 115,000. It's close, but it's not accurate. Please do this, guys. Open the collab file. Now implement it. Start working on it. Data set I given you already. Start.
Which means 20% shows that 90% accuracy.
Yes. Okay, based upon this 20% data, we are checking how much your model is accurate. Okay.
Oh, okay. We already make 80% before the machine is training by 80%.
Yes.
So right now we test the machine to how much accuracy it's okay. Thank you.
Yeah, Govind, if you train and test with 50%, 50%, yeah, there are chances it might increase the accuracy.
No, it will decrease the accuracy because your machine will get less data to get pattern.
Okay.
Testing, see, you are learning for 6 months. If I have to test you, you are good at it or not. I just need to ask 2-3 questions to you. I'll just take a 30-minute interview, right? I'll be very clear, right? So if your training time is 1 year, you might learn more things, correct?
Okay.
You will have more time to get revision. So as we keep on increasing the training data, the chances are very high that our model will learn better. Okay, it has the idea to see all the type of data. Okay.
Okay. How about 90-10?
This is also fine. This is also fine. Depending upon the amount of data, what situation it is, you can customize it. But 80-20 is the general rule. Okay. If you don't use the brain, just apply 80-20. Okay.
Oh, okay. Good.
Can I ask a question, sir?
Tell me.
Yeah, please. What of the computing the loss?
Loss we are not computing right now. Loss is the separate topic. In the next class, I'll discuss what exactly loss is, what are the expression and formulas. Then in the same hands-on, I will add the loss also. Okay.
Oh, okay, sir. Okay.
Yeah, it's a
Because
separate
it's part
topic.
of
I'll
the 10
discuss
steps.
later.
So,
Yes,
okay, sir.
yes. We did not compute the loss. Yes, it will be at the end.
Oh, okay. Okay, sir. Yes, sir.
Well, okay. One question: If what will happen if we take 80% for a training and when 20% for accuracy checking? What will happen? The result is under 50 or 70 or 80. What we will decide for us?
It will also produce the same thing, but it will not be creating a robust model. Robust model is the one which is being trained upon large amount of data. Okay.
Can
So
I ask a question, sir?
80% data is the sufficient data.
Okay. Thank you.
A special security announcement. Can I ask a question, sir?
Yes, tell me.
So down that we had 90.2% accuracy. Is it can we be able to like increase our train
Yes.
data and then make it like about 85 or 90 and then test with 10%? Would that change
Yes,
the
yeah,
accuracy?
yeah, definitely it will change. Of course, 100%.
Okay.
Guys, done with the hands-on? Completed? Everyone?
Yes, for me.
Getting the output?
Yeah, Govind, yes.
Yes.
Good. Okay, in the next class, we will be discussing about multiple linear regression and the loss function, okay, of each one. And if for more clarity, I request you to please watch the session recording of this class, okay, before coming to the next session. Fine. So that will be helping you for revision if you have a bit of confusion and all.
Okay.
Yes, sir.
Okay, thank you.
Yeah. Thank you. Take care.
Yeah.
Thank you. Appreciate.
Yeah. Hello, Mrigan.
Hi, Govind. So there's
Yeah.
no class today?
Yeah. And now your class will be like for Azure training. Okay. Team will be sending you the email for Azure training and all.
And actually, I'm a little bit sick, so that's why I couldn't attend your yesterday's class. So what
Yeah.
did you teach yesterday?
It
I
was
couldn't find any.
Google Data Studios and all we
I
covered.
didn't find
And
any videos on that. So
it will be maybe team might have not uploaded this. So Google Data Studio we actually covered. Okay. It was very basic tool. It does not have lot of features. But yeah, I gave the introduction what exactly it is, how you can operate on, and one platform, Gen AI platform called as Google AI Studio. Okay,
okay,
this
please
thing.
upload the video. That would be very
Team
helpful.
will update today. No issues. I request.
Okay.
I send them.
And so then, what happens next? Because this
Your
batch is
next
over.
week, yeah. So you will be receiving one project, caption project from the team. Okay,
Mm-hmm.
for your batch, and you guys have to submit it in next 2 to 3 weeks. That project, and then only your Azure training will be starting up.
Oh.
We will be sending you the proper guideline for data set and everything for the project. Okay.
Okay.
Team will share
And
on the email.
is this about the Microsoft training thing or?
No, project will be the thing you have covered in the classes,
Okay.
and Microsoft will be different cloud services you will be learning. Okay.
Somebody is teaching us or?
Yeah, somebody from Microsoft team will be coming up and will be handling you.
So it's not you, right?
No, I will not be the trainer for Azure training. Yeah.
So someone else will come and teach about this training, Microsoft
Yeah.
testing. Okay.
Yeah. Hello,
So
Rejani. I think you were also not there yesterday. Got clear?
No, I was there.
Okay. So I told him that there's no class today.
Oh, okay.
Okay.
Okay, I was not
Just wait
sure.
for
I
tomorrow.
heard it.
Yeah, tomorrow you will receive the project from the team.
Yeah, the project out. Yeah, you
okay.
mentioned.
Yeah. Thank you for letting me
Okay.
know.
Okay,
Thank you.
Corbin. Thank you so much. We really appreciate your help.
Yeah, I
You
really
was very
appreciate
patient.
your class.
You was very patient with us.
Yeah, I really
Thank
appreciate
you.
your class, Govin.
Yeah, thank you so much. Okay,
Okay,
take
then
care.
I'm gonna leave now.
Oh, no, okay,
Yeah,
problem.
same here.
Okay,
Thank you.
okay.
Have a good
Thank you.
one. Bye.